Welcome to the Institute for Catastrophic Loss Reduction's forecast webinar before this already extraordinary 2023 wildfire season. It's Tuesday, June 6, 2023. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. This is one in an annual wildfire forecast webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. Just like in previous years' fire forecasts since 2018. Today's speaker is Richard Carr from Natural Resources Canada. Richard is one of Canada's most respected fire weather experts. He is a geographer by education with about 30 years professional experience specializing in meteorological modeling, especially for near real-time and historical wildfire meteorology. Fire agencies across Canada turn to him for fire risk forecasts, including his own Canadian Forest Services Fire Group within Natural Resources Canada, also the Canadian Interagency Forest Fire Center and federal emergency response agencies. To learn more about a key product of Richard's work, Google Canadian Wildland Fire Information System. Before our speaker begins, here's our agenda. Our webinar will last about 60 minutes. Our speaker will present for about half or three-quarters of that time, and then I will moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I will try to pose your questions in the order they appear in the Q&A box, and if we have a lot of questions, I may only pose your first question, then move on to others, then circle back to your additional questions. Our webinar is recorded, and ICLR will post our speaker's slides and a link to the video in the next day or two. So if you have colleagues who couldn't attend, please let them know. And with that, I will turn the presentation over to Richard.
All right, thank you very much, Keith. And welcome everybody to the 2023 Wildland Fire Seasonal Forecast. We're doing this one about a month later than we've done in the past. Most of the previous presentations have been in the middle of May, so we're into June here now, and so the way I approach this is a little bit different, and especially with this fire season already well underway or too well underway. So we've got a bit of a story to tell already about the fire season. So we'll get into details about that first, and then get into the actual forecast later. So, I mean, the title of the slide is, whoa, what's going on this year? It's a crazy start. We've already burned more than the average total that we have annually for most years. So the average fire season in Canada sees about 2.5 to 3 million hectares burned. So we're over 3 million hectares already. So pretty incredible start to this year. The map that you see is from the Canadian Wildland Fire Information System interactive map from June 2nd. So the circles are active fires at the time. The red ones are out of control. The yellow ones are being held, so that means that suppression crews have got a handle on them, and they're not expected to grow outside the existing perimeters. Well, there's still active burning going on in those. And the blue ones are under control, so they're probably well on their way to being extinguished. You can see a few hotspots, star-shaped symbols in there as well. A lot of those are obscured by the fire circles, so sometimes you can see a big cluster sticking out from underneath the circles, such as northeastern British Columbia and maybe the Southern Territories. We'll get into a bit more of those details in a slide or two here. So a few statistics to date, and right at the top, we've got a italicized comment, and this is just the rough wording that I quoted to one of the reporters earlier in the season. Kind of asked, how much area burned had taken place already and how many fires. And at the time, I said I didn't really want to comment on that since the numbers are changing so fast that they become outdated by the next day. And it's very true this year. If we report a number on a specific day, well, it's going to be quite a bit different by the next day. So a very rapid progression of the fire season in 2023. Anyways, in spite of saying that, the numbers from June 5th, just for a bit of reference here, had 2,266 fires at that time. Area burned is approaching 3.6 million hectares, and so we're already quite a ways above our annual average. The 10-year averages for early June, approximately 1,700 fires and maybe 270,000 hectares burned. So, we're sitting at more than 10 times the average area burned for the time of year. CIFC, the acronym CIFFC, is the Canadian Interagency Forest Fire Center. So that's a little organization in Winnipeg that coordinates the exchange of resources between provinces in Canada, and also helps exchange resources between Canada and other countries. So they have a preparedness level, which is based on the availability of resources in the country. It's been at 5 since May 11th, which is the earliest on record. A little colored scale there gives an indication of how the scale progresses. So the one in blue is very quiet. We see that at the start of the fire season, usually when nothing too much is happening. Number 2 is pretty normal as well. By the time we get to the yellow number 3, well, we're starting to see at least a couple of agencies that probably are starting to exchange a fair amount of resources. They've got some fire problems and they might require some help. So there's some exchange going on at a fairly rapid pace. And when you get to a level 3, we're actually kicking a few other operations into gear to help prepare for acquisition of international resources, people from the USA or Australia and New Zealand and so on. At preparedness level 4, it's starting to get fairly critical. Our Canadian resources are getting stretched pretty thin. And at 5, we've probably committed all of our Canadian resources and have drawn fairly heavily upon international resources and maybe military support as well from the Canadian Armed Forces. So that's where we've been at for almost a month now, which, as it says, a record earliest onset of preparedness level 5. And we don't know how long it's going to go on for, but it could set a record for the length of time as well if things carry on the way that they are. So Canada's got agreements with a number of countries: the United States, Australia, New Zealand, Mexico. The ZA is not Zambia, it's actually South Africa, Costa Rica, and we do have discussions ongoing with other countries as well, places like France, Portugal, even Chile in South America. The countries that we've got listed there, we've got people in from them already. South African should be arriving just as we speak, I think, sometime this week. Mexico could supply people, but their fire season, I think, has been going on a bit longer than usual. It usually wraps up in May, so they haven't committed to sending people up here yet, but we might still be able to draw upon their resources in a few weeks. I don't know if anybody's familiar with the CIFC webpage, the Canadian Interagency Forest Fire Center webpage. The situation report there has been reworked, so it looks a little bit different than it has before. Just thought I'd throw in that. It doesn't really change much, but the web pages are changing. Now, if we look back, 1989, that held the previous record for the most area burned in Canada in one season. So 1989 featured about 7.5 million hectares burned, just a little under half of that in Manitoba alone. So if you exclude Manitoba, we'll still got another 3 or 3.5 million hectares or more burned in other parts of the country. So in spite of Manitoba having a huge fire season, the rest of the country contributed above average numbers burned in 1989 as well. What was the weather patterns like in 1989? Were they similar to 2023? Perhaps. Both years featured a fading La Nina. 1989's persisted later. It tended to die out in late spring, I think. And then there was a long period of ENSO neutral values from middle of 1989 into early 1991. And a lot of the country may have more area burned in that ENSO neutral period. We've seen British Columbia have large area burned in years like that. Drought was fairly prevalent. That long kind of ENSO neutral period may have prolonged drought during that period. So although I think it was probably worst in northern parts of the provinces and maybe up into the territories. Unfortunately, I don't have all the information I hope to have on hand to show that. Our website, Canadian Wildland Fire Information website, is getting hammered pretty hard, I think, by usage right now. So I wasn't able to pull up some historical maps that I would have liked to have shown. Now, I guess since 1989, if you throw in 30 years of climate warming, it might have contributed to the rapid start this year across multiple areas in the country. We also had better detection and suppression methods currently. So in 1989, 30 years ago, probably didn't have quite the capacity of detection or people out in the field. So, we've got cell phones, we've got better satellite detection and things like this, and more advanced suppression methods, and probably better exchange methods between provinces and countries as well. So I think some key differences there. We'll see what happens in 2023 as things go on. So with the area burned increase, the black line on this chart towards the left shows the 2023 area burned, and this map is derived from aerial estimates from hotspots. So these are thermal signatures from satellite instruments. So it's not 100% accurate, but it does give a good indication of how fire seasons can progress. So we've seen a very rapid increase, very similar to 2016 with the Fort McMurray or Horse River fire. At the beginning, through May at least, but 2023, the numbers just kept going up, while in 2016, they tended to level off. And a little bit of a difference I'll get on into a bit later in the presentation there. Some other things you can take from this graph are rapid increases in the spring, then a bit of a leveling off as we tend to get best rainfall through latter half of May, mid-May until probably about mid-July. Then when things get hotter and drier through the later summer, then we see that rapid increase take off again once we get into July and August. But, it's hard to say what the graph in 2023 will show. It's going up right now. We've still got some pretty dry areas in the country and lots of active burning. I think another thing that's quite notable here is 2020 is that horizontal green line at the very bottom. And so we've gone from pretty much a record low area burned a couple of years ago to this year, which could set a record if things keep going the way they are. I'll just walk through some of the hotspots and fire progression here. So very similar to the first slide that we saw just after my introductory slide. Looking at CWFIS map on May 1st, you see a few active fires in Alberta, northeastern BC. Not too many that were huge at the time, but we did have a prolonged windy and dry period with fairly warm temperatures through that period. So we kind of expected area to grow fairly rapidly. Some fires in Saskatchewan that are represented by the blue circles, so some of those got pretty big, but they're under control fairly easily. A week later, though, or not even a week, I suppose, May 6th, we see a large number of out of control fires, all the red circles. A lot in northeastern BC, Alberta, a few in Saskatchewan, and some smaller ones as we get a little further east through the country. A couple of weeks later, May 20th, well, we've seen a lot of fires progress in Saskatchewan. The number in Alberta maybe didn't change too much, but maybe seeing a bit more activity in the far north and up into the Northwest Territories as well as some out of control fires along the south of Great Slave Lake and then along the Mackenzie Valley, just north of Fort Simpson. And recently, June 3rd, well, it looks much the same except for the east. Now we've got a lot of active fires in Quebec, and the first few days of June saw a huge number of lightning-caused fires in Quebec and some in Ontario as well. Of course, in the Atlantic provinces as well, a number of fires in New Brunswick, and I'm sure a lot of people are familiar with the fires in Nova Scotia that forced evacuations and damaged homes there. And fortunately, they got a very good rainfall over the past couple of days, and up to 150 millimeters or more in some places. So I think they're in much better shape in Nova Scotia and New Brunswick. Some of that rain is probably going to affect southern Quebec over the next few days, but doesn't look like it'll make its way towards the western part of the province. So I expect a lot of active burning to keep taking place closer to the Ontario Quebec border and west of that. So why may this have happened? A few facts or anecdotes here. We do have changing INSO conditions. We've got the fading La Nina getting back into a, and so neutral briefly through the spring, but sea surface temperatures are showing very warm through the eastern Pacific. So we're heading into an El Nino. It looks very definite. I don't think we're quite there yet. We need about 3 months of sustained half a degree temperature anomaly in the Nino regions. I'll get into that a bit later as well. But I have been learning that transition speeds of these indexes may be actually more important than the actual maximum and minimum. So if we get a very rapid transition, well, maybe we've got influences of both features going on at the same time. I did hear from one of the US climatologists in Washington State that they recorded their warmest May on record. We've had very warm weather in Western Canada through May. We don't have the numbers yet to say if we've got the warmest May on record, but I wouldn't be surprised if some regions have recorded the warmest May on record. We've had a fairly persistent drought through the west since late 2022, so we'll walk through a few of these slides as well. So the first one that we see is the end of August 2022, so kind of patchy drought through Western Canada and a few spots in the east. It looks fairly normal, but by the time you get to the end of December, well, that drought just intensified through the late summer and the fall, and by the end of December, it was quite widespread through Western Canada, still patchy in the east. A few months later, at the end of March 2023, there's been some reduction in drought, especially in British Columbia, since we can get some fairly good moisture through the mountainous areas and even into the interior a bit through the winter and spring. Still fairly elevated levels through Alberta and up into the territories and eastward through Saskatchewan and even into Western Ontario. And more recently, at the end of April, just if you can't read the fine print there, these maps are produced by Agriculture and Agri-Food Canada, and I was hoping they'd have their May 31st map posted by the time of this presentation, but I wasn't able to access it, so I'll look at April 30th. So we've got fairly similar levels, I think, as we saw at the end of March. Maybe a bit of reduction in far western Ontario, bit of an increase through the Atlantic provinces. We see that patch in Labrador and the Eastern Townships region of Quebec going a little bit. And we see a bit of the brown starting to show up in eastern New Brunswick and western Nova Scotia. So represents a moderate drought that was forming in that area. If we did see the May 31st map, we'd see a bit more intensification again in Western Canada and probably more prevalent yellow to brown, the abnormally dry to moderate drought in Eastern Canada. Might be getting fairly widespread through that region by now. Snow dips, they actually affect the spring fires more than summer fires. You can have a really good snowpack in the spring, but you know, if it melts off and disappears, it doesn't really affect the summer fire conditions much. In the spring, there's a few things that affect the snow melt, how rapid it is. If you get a lot of quick melting, you probably get a lot of runoff and not too much water percolating into the soil. And if it melts when the soil is frozen, once again, it may run off and just disappear. So it can affect the spring fire conditions, but not too much in the summer. So the first map is from April 26th, 2023. The red line there gives the mean location of the 2 centimeter snow depth for that particular date. So we can see any white above that line, such as around Great Slave Lake, parts of northeastern Saskatchewan, have lost the snow cover a bit earlier than usual. If there's colors south of that line, such as in parts of Western Ontario, then the snow is hanging around a bit longer than usual. Stepping ahead to May 10th, we see a lot of white above the red line there in the Northwest Territories, northern Manitoba, and in northern Quebec and Labrador. So those areas lost snow cover a bit earlier than usual as well. We did have a patch in north central Ontario, just west of James Bay, that had snow cover lingering quite long into the spring. So that bright green area there is representing a few centimeters snow depth anomaly for that particular date. By the time we got to May 17th, a week later, that had disappeared. And these particular maps I present weekly for the weekly fire weather briefings for the duty officer calls at the Canadian Interagency Forest Fire Centre. So May 17th represented the last snow cover map that I presented during those briefings, just because most of the snow cover had vanished in the forested areas and we're left with a mostly white map to look at. Looking at sea surface temperatures, this particular map at the base here is from January 10th, so we see a lot of blue indicating below normal sea surface temperatures in the Central Pacific. The red box in the middle there that says 3.4, that's the region of the Pacific that the El Nino Southern Oscillation Indexes are taken from ocean temperatures at least. It's also a wind that factors into that, but I won't be showing the wind data during this presentation. In the red ovals above that, we're looking at temperatures in the North Pacific, and those can represent the Pacific Decadal Oscillation. And on the East Coast, the area just off Newfoundland, Labrador, and around Greenland is important, could be important for what happens in Eastern Canada as well. Now, if we step ahead to a recent date, looking at June 3rd, we see a lot of, a bit of warming, I guess, along the West Coast. Bit of cold water below that along the coast of California and off the west coast of Mexico. But what is quite notable is the rapid increase of temperatures in the Nino region. So going back, it's fairly blue, and by the time we step ahead to early June, well, we see a good plume of warm water off the west coast of South America, extending into those Nino regions at least partway. So a very rapid warming of those sea surface temperatures there. At the same time, on the east coast, we see a lot of cold water off the east coast of Canada, and that may tend to influence or strengthen high pressure areas in that region. Quite often when you see a lot of cold water, it tends to increase high pressure. We see that in Australia if they get the cold water on the west coast. That's the Indian Ocean dipole that affects that. You can get a lot of drought, increase in temperatures in the west part, which is mostly desert, and that tends to translate across the rest of the continent. So Eastern Australia can also be affected by that. So we might see similar effects in Canada as well with the big regions of cold water. Some hard problems in Enso Springs. So we've got we're probably close to 30 years history here. Unfortunately, we don't go far back enough to capture a previous biggest year, 1989, with area burned, but we had a large area burned in 1995, 1998. Those were both El Nino years, so kind of the opposite Enso phase that we've had recently. 2001, we had big fires, spring fires at Chisholm, Alberta. That was a fading La Nina, once again coming off a very extended period of La Nina there. So all of the blue numbers on here represent La Nina years, and red one's El Nino. Black is in neutral territory. Slave Lake again, 2011, La Nina, fading La Nina. Faded a bit later in the spring than we did this year, but still very similar patterns, I think. And just at the very bottom in the red box, we've got 2023. So we only got the 1 month, January, that we're still in full La Nina mode. Still a bit negative in February and March, but getting much back into neutral territory by that time. So later or earlier fading of the La Nina this year compared to previous years. So what happens in the La Nina years, well, we tend to get a lot of Arctic surface high pressure areas that move usually into the central or eastern prairies, bring a lot of dry air. It's very dry. They are fairly strong features, so we get a lot of wind around the edges of those, and we saw that in early May through Western Canada. Temperatures may be cool, but they're quite often quite normal through Western Canada during these episodes. What's different though in 2023 is we actually had very warm air in conjunction with the dry and windy conditions in early May. So That looked a lot more like an El Nino spring where you tend to get a fairly warm, dry winter and fairly warm conditions. And quite often in the El Nino springs, we tend to get our hottest temperatures in May, and then the rest of the summer is a lot more moderate. This year really looks like a combination of both influences with a lot of dry Arctic air dominating parts of the country, but some very warm temperatures as well. Just in the orange boxes there, we've got some other problems that crop up in BC during the neutral ENSO years. So a lot of those years are highlighted: 2003, 2010, 2014, of course, 17 and 18, and the western half of the country in 2021. Okay, so we've got the trend of Pacific decadal oscillations. With the extended La Nina, we tend to get back into a negative PDO. So we can see that with the blue part of the graph right at the very right-hand side. So we did have a bit of a flip, I think, temporarily in the mid-2010s. But then we got into this extended La Nina period, and might tend to influence things in Western Canada especially. But yeah, with the rapid return of El Nino, we might see more of a return to the positive PDO, and with that, it can maybe reduce precipitation in southern parts of the western provinces. So, we'll have to watch that closely and see what happens as the years go on here, or the months go on, pardon me. The opposite end of the country, the North Atlantic Oscillation. We've pointed out some big fire years in Quebec, so those are represented by the black arrows on the chart at the right. They're in red on the numerical chart in the middle. So the biggest year looks like 2013 with 1.9 million hectares burned. Other big years are 2010, 2007, 2005, 2002, and 2023 will go down as one of those. And what we've noticed with those is they quite often occur near transitions of that North Atlantic Oscillation. So we're maybe going from a negative to positive or vice versa. So it may be getting an influence of transition from a fairly dry period into more of a troughing or wetter period in the eastern Arctic, and possibly it may contribute to more lightning following those dry periods, which could start a lot of fires. So we'll throw in 2023 there as well. And with that, I've been learning more about influence on the western edge of that as well. It's called the Baffin Western Atlantic Oscillation. So with that, we're looking at pressure patterns along the 60th 60 degrees west longitude and between 30 and 65 degrees north. So that may actually have a more direct influence on fire seasons in Eastern Canada, maybe a better indicator. So I think in future years, we'll maybe have a bit more information on that. Now, I'm just going to step back in time a little bit with our seasonal forecasts. So just in the heading there, we've got the April run highlighted in violet, just because this was a forecast produced a couple of months ago, but it's another thing that really caught us by surprise, and we'll go through some of the details of this. So our April forecast for May and June didn't look too spectacular. We had some areas in the central part of the country that were highlighted in May, and a bit broader area through June, but nothing that really indicated the volatility of this fire year. In May, we did have that area highlighted in the dashed line. I always point that out, that winds can really influence the fire through western Saskatchewan, a lot of Alberta and northeastern British Columbia at that time of year. It tends to be the windiest time of year. Spring is windier than most other months, except maybe along coastal areas where the winds tend to be strongest during the autumn, more of a stormy time of year. But in Alberta, May fires are quite prevalent. They don't burn the area burn that we're seeing this year, but out of all the provinces and territories, Alberta has the most spring area burned in May. So we always like to point out that area of influence. However, I'm just highlighting this is not the most recent forecast, just from April. If we step into our May run for May and June, well, all of a sudden we've seen a huge difference. We've gone from very tame looking May forecast and kind of a so-so looking June forecast to having bright red across a lot of Western Canada, indicating well above fire potential for a very large area. Once again, that's not the most recent forecast. We'll look at the June 1st forecast a bit later here. So why did the April and May forecast differ so much? Well, we base our forecasts on, first of all, the Canadian Forest Fire Danger Rating System that we have information in our Canadian Wildland Fire Information System that we draw upon for that for the most recent fire weather conditions. And we use forecasts of temperature and precipitation from CANSIPS, the Canadian Seasonal to Interannual Prediction System. And we'll talk about the details of that on the next slide. But inside the blue circles, those represent the same times a year from both the April and May forecasts in just for one location. This is Lawrence, Saskatchewan, and just picked out a location more or less at random just to highlight what was happening. And on the left is the April forecast. All of the pink lines in there are forecasts from what we call an ensemble member. So similar climate models, just maybe with some different physics or different initial conditions, all trying to predict the same thing. The black heavy line in the center of that is the actual median that we base our anomaly on. So we can see that at the top, we've got temperature. A lot of those pink lines are below the black line, indicating cooler than normal conditions expected in La Ronge for that spring period. The bottom one is CM4I, which tends to predict warmer most of the time. And we do see the lines above that black line from the April forecast. Moving on to the right-hand graph, all of a sudden with the temperature anomaly from the gem Nemo at the top, which normally has kind of a cool bias, we start to see it predicting above normal temperatures through the probably a good portion of the spring and possibly into the summer and maybe later in the year as well. At the same time, the CM4I at the bottom right there bumped up its warm predictions. So it always is forecasting a bit warm, but suddenly started showing much warmer conditions. And I think what is most notable, though, is the gem Nemo, the top one, really starting to show a warm prediction when it's normally got quite a cool bias. So these models really picked up on the possibility of fairly hot conditions, I think, through a lot of Canada once we got into May and June. I'd have to leave it up to the developers of the climate models to really give a good idea of why the models suddenly flipped, but it may have to do with the transition of ocean atmospheric indexes. That's a question for their experts and probably not mine. All right, with the CANSIPS model, they're developed under Environment and Climate Change Canada, specifically at the Canadian Centre for Climate Modelling and Analysis, which is in Victoria, British Columbia. So the two models that form the ensemble models for that are the CM4I and the GEM, I should say GEM5 Nemo there, it's changed a little bit. There's the expanded acronym if everybody wants to know what GEM Nemo means. Each of those consists of a 10-member ensemble. They forecast out for a 12-month period. We just run our forecast from March through September. We are pondering whether to extend that a bit later in the fall too. We've had some fire seasons that go into October, and it may be worth considering extending our forecast into October at least. Out of those, we use temperature and precipitation data on a daily basis and calculate our fire weather indexes going out throughout the year. The skill of these forecasts are often best in coastal areas, maybe not quite so good in the lee of mountain ranges, so across the prairies and maybe parts of British Columbia at times, and I'll show a bit more information on that later. Very briefly, the Canadian Forest Fire Weather Index system that we use for calculating our data there. At the bottom right is the green box, so there's a DSR, MSR, and SSR, so those are all severity ratings. We calculate those on a daily basis, so that's a DSR. For the purpose of our forecast, we roll those into monthly or MSR values and compare that with the historical means. So that way we can determine which areas are showing above or below normal monthly severity ratings for each month. Into 2023's seasonal predictions, and the big question is what happens now? And really, it's not something we can say with certainty. First of all, the ENSO forecasts. The black bars there give the indication of where the sea surface temperatures are to represent an El Nino. The top black bar, temperatures are warmer by 0.5 degree for at least 3 sustained months. The lower one is the La Nina, cool temperature anomaly of 0.5 degree, so 0.5 degree below normal for at least 3 sustained months. There is a mixture of dynamical and statistical models here. There is a bit of a discrepancy between the two. The bulk of the lines at the top of the graph are actually the dynamic models, and the ones a bit lower down are the statistical models. So you actually see them grouped into two separate clumps here for the most part. But still they're predicting a return to El Nino conditions over the summer, and it looks quite probable once we get into July we'll actually be into an El Nino state. This can also influence what happens in 2024, and if we have a sustained El Nino, we could have a warm winter in the west and a warm spring with windy conditions and warm temperatures in 2024. So quite important that we follow what happens with the ENSO forecast here as well. Just on the right is historical values, and we can start to see that positive anomalies start to crop up at the very right-hand part of the graph here. We've got a tiny little red spike there that's starting to show a bit of a return to a positive index. Going into the North American multi-model ensemble, this uses models from both Canada. Those are in the green box, the CM4I and the GEM5 NEMO, and some of the American models. Top left, it's all rolled into the national or the North American multi-model ensemble. So it's kind of a summation of results from all those models and average, I guess, or something similar. So just pay attention mainly, I think, to what we've got in the green box in the middle, and you can compare it with the other boxes around from different models. Just at the bottom right, there is European models that are built into this as well. So the International Multi-Model Ensemble. Of note, the GEM5 NEMO quite often predicts a cool bias, but these are taken from the middle of May, so a couple of weeks old, but we've got very similar forecasts from May or June on our system, and a lot of these I think will probably show similar types of results. So where we've got red, we've got indication of forecasts of warm temperatures, and looks very prevalent through the center of the country here, especially on the CM4I, but the GEM5 NEMO, which quite often holds large pools of cool air across Western Canada in the spring, is predicting warm temperatures as well all of a sudden. And we look at precipitation as well, which is a lot harder to forecast. So we see probably a lot more differences between model forecasts on here. So we're looking at June forecast here, the CM4I and the left part of that green box in the middle suggests good precipitation through northwestern BC and up into the territories. And we're seeing a bit of that happening right now. I don't know if it'll be sustained enough for the model to do a good prediction there or not. Possibly on the coastal areas. Do see a bit of a green dot in southern Alberta, but drier conditions up through the north and especially through the central part of the country. So Manitoba, Ontario, and possibly Western Quebec. The GEM5 NEMO on the right there, a much more extensive dry area predicted. Look around at the other models and get a sense that there's some differences between them, but a lot of them do favor that central part of the country being quite dry through June. Stepping into July, temperatures maybe get backed off a little bit with the models, but the CM4I is still showing very warm anomaly through the central part of the country, really extending coast to coast, but the epicenter of that is probably Ontario and Western Quebec. GEM5 NEMO shows a bit of an influx of cooler air into the southern prairies, which could be possible if we get better precipitation through there, but still favoring dry conditions to the north. And a lot of the other models are still favoring fairly warm temperatures through large portion of the country. So could still see a lot of above normal temperatures through July. Precipitation, well, it's a little harder to say for sure, but we're still maybe seeing a better signal through northern parts of the country, Northwest Territories, northern parts of the prairies, and possibly northern Ontario. Into August, probably maybe a return to warmer conditions through a lot of the country. We're seeing maybe a more prevalent warm signal again. Gem 5 Nemo is maybe pulling in a bit cooler air, a bit more moisture through Western Canada, so it's got that kind of a return to kind of a cool pull of air through there, but a lot of the other models aren't really reflecting that extent. Although there is a bit of a hint from some of them that there may be a bit of an influx of possibly cooler, moisture air in through the west. Precipitation, well, the Gem 5 Nemo does have a fairly large area of above normal precipitation through Western Canada, maybe extending out to the Great Lakes. So, that's representative of their cooler forecast as well, but not all the models suggest that, although a fair number of them do suggest fairly good precipitation in parts of the country during that period. But as I say, the precipitation is much harder to forecast, so we really have to keep that in mind. There are skills maps that are produced, so you can take a look at how the models do. And of course, the farther you get away from the initial forecast date, the worse the skills get. So with these, we're looking at a 2-month lead. We're looking into July from the May forecasts. Temperature at the top, precipitation at the bottom. Where we've got some color, yellow indicates probably the lower threshold of, I guess, prediction accuracy. Once we get into green, well, we might be seeing some type of a fairly reliable trend. And if we get into any of the pink colors, then it's very definite. But unfortunately, most of those occur off the coasts and not over the land masses. I do see maybe better predictions of temperature through eastern Canada and kind of some more spotty areas through the rest of the country. At the bottom, precipitation skills are quite lacking, and you see a lot of weight in those areas. It's indicating virtually no skill and prediction. I do see patchy areas where it might be a bit better around southern Vancouver Island, for example. Maybe spotty areas on the east coast, but in between, not too great. However, having said that, to the Gem 5 Nemo on the right maybe shows a little bit better skill at predicting precipitation than the CM4I. Although the CM4I could be a bit better at temperature, so it's kind of a toss-up between the two models. Into our actual seasonal prediction. So this is the latest forecast from June 1st here. So we have seen a bit of an increase in the area that's highlighted for having high potential, much above average potential. So, and even the above average extending into the Atlantic provinces through June. Get a bit of a reduction in July as it starts to reduce the area in the eastern Canada, but keeps it pretty intense through the west. August and September, a lot of red areas still showing up in August. So, if you do have fairly ingrained drought, it does take a lot of rain to alleviate that. So you can get wet periods, but a few dry days can kick up fire activity again. So by the time you get into September, the area is starting to shrink as you'd normally see, but those deep burning fires can go well into the autumn. So, keep our eyes open on what happens throughout the summer and early part of the autumn. Usually point out where you can find these maps on the Canadian Wildland Fire Information System webpage. So that's where that orange arrow points to. We are in the process of redoing our website completely. So at some point it will look very different than what you'll see right now. And as I mentioned earlier in the presentation, our website is just getting hammered with usage right now, I think, so it might be very slow. A few conclusions and reminders. Model consensus points to a fairly warm summer with many dry areas, but we might see a bit of a respite in July with better rainfall. And there's possibility it could carry on into August, although usually August tends to be A bit drier than July, so it's you really have to keep that in mind as you get into the late summer. We can have serious fires occurring in any year if they just happen to occur at a bad location outside a community. Well, it can have some fairly serious effects, and sometimes you can get a fairly dry spot in the country, and you get a big fire that occurs there, even though the rest of the country may be quite wet. Fire activity does depend on ignitions. So, our forecasts only point where the weather conditions suggest there is an increased potential. So we are developing models that predict lightning ignitions and human-caused ignitions, but those are not built into our seasonal forecast. So just a reminder to check updates on the first working day of each month on the CWFIS for the latest seasonal forecast. We do monitor daily conditions across the country. People can rely on provincial websites as well to keep up to date with the most recent fire occurrence and fire weather index trends. So there's my contact information. So with that, I'll just turn it over to the audience and see if there's any questions or comments.
Great. Thank you so much, Richard. We have one question so far, and I have a couple of my own. But
All
let
right.
me play Sandy Johnston's question. I think you answered this around, or you addressed this a little bit around slide 30. But Sandy asks, is there modeling of wildfire risk based on the prevalence of lightning? And would it show anything different from models based on air temperatures?
Yes, with precipitation, it's probably tough to get a good prediction of lightning too far in advance. There are some products out there from some of the meteorological agencies that will predict lightning a few days ahead of time. But when we're looking at a month or 2 or 3 months down the road, it's probably fairly tough to get a good prediction of where lightning will occur. There are, however, people that are trying to address that problem. I just don't think we're in a good position yet to try to present anything on that.
Okay, thanks. And I have, while we're waiting for other questions, I have two, one shorter term and one longer term.
All right.
The shorter term, around slide 5, you showed us accumulated area burned
Okay. So I'll
by the
just
season. And 2023 was almost reaching record levels for entire years in the past.
yeah.
And then around slide 29, you showed us a lot of red for July and August. That one exactly.
Yes. Yes.
So and we're only a little way into the season, and then toward the end you showed us a lot of red in your forecast for July and August. Do you have a guess, or would you be willing to offer a guess of where you see 2023 going? Where that black line is going to go?
Yeah, I mean it's something that's definitely on our minds is that we could have a record-breaking area burn this year. So we're about halfway to that point now, and we still got a lot of fire season to go. I think with models pointing to probably a fairly sustained dry feature in the central part of the country. Um, I think we could, our trend will still go up. We don't see an immediate return to rainy conditions in some of the drier areas, so we're going to keep picking up a lot of area burned as we get through June. Possibly in July, if we do get a bit of an increase in rainfall, it'll tend to create a bit of a shoulder there, but um, it's possible areas can pick up a bit more area burned later in the year as well. And I think this is what I'm hoping will happen, with the El Nino developing over the summer. It may tend to bring in a bit more regular moisture, at least to southern parts of Canada. Unfortunately, with the El Nino, I think it tends to favor a bit of a drying through the Northwest Territories and maybe northern parts of the provinces too. So they could remain fairly active. Once again, it's just in its formative stages, so I don't really know how fast those changes could come about. If you have a sustained El Nino, well, maybe 2024 to have good summer precipitation after maybe a warm and dry and windy spring. So yeah, there's some of those influences that I don't really know the answer to. And as I said sometime during the presentation, that the transition of these can be equally as important as where they end up. So yeah, a lot of unknowns, but some hints at what we might see.
Okay, great, thanks. So now we're getting several questions come in. An anonymous attendee asks about this slide. What happened in 2020 that contributed to the lack of fire activity?
Um, yeah, I think we had regular rainfall, maybe not heavy, but it was just regular and widespread, I think, throughout the country. And I'm just going to step ahead again here a little bit. And with all these animations, takes a little while to get there.
Yeah.
um, so it's kind of an oddball year. If you look at the ENSO trends there, we have a lot of black numbers heading into there. It's fairly neutral, and we really expected a bit more activity than what we got. We did go into a La Nina at the end there, so latter half of 2020. So yeah, it's really kind of an oddball year. I think that maybe defied expectations as well, and um, just like 2023, it kind of took us by surprise. So uh, there's all sorts of factors that go into this, and um, I think one thing that maybe affects this year is we've seen some studies that are pointing to with climate change more of a what we call a meridional flow of air. It's more north to south instead of west to east.
Mhm.
So I think that might have influenced our spring fires this year with a lot of meridional flow. We get the Arctic air masses coming into the central part of the country. You got a lot of wind around the west, and a lot of drying. But I think maybe 2020 was maybe just the opposite, where we had more of a better flow off the Pacific, more of a consistent flow. And there's probably a lot of influences out there that could contribute to this that we haven't touched on here.
Okay, great.
Yeah.
Thanks. ICLR Executive Director Paul Kovacs asks, Richard, please tell us more about the satellite system that will become available to support wildfire management in Canada.
All right, that's the Wildfire Sat. It's being developed by the Canadian government, and it's a long process. It takes a long time to plan the mission, design the instruments, and get funding, get the technological experts to build it. It's being funded by the government. So um, although I think a lot of the development is being outsourced to remote sensing technological companies to actually do the instrument development. So its planned launch is in the late 2020s. So it'll be more dedicated to actual detection of fires, not just in Canada, but will be available globally upon request. Within Canada, the hopes are is that data will be provided free or at a nominal cost, if any, just because it's a government funded project and government operated project. So there are other high resolution instruments out there, but they're not really dedicated to fire detection. With the Wildfire Sat constellation, we'll have overhead passes at critical times of the day, so late afternoon. So we have the peak burning conditions in the late afternoon and early evening in most cases. So we should get better information at that particular time of day. I think it will have a kind of an aimable feature there too, so might be able to zoom in on particular incidents as well. So a few advantages to the Wildfire Sat system. We've got Joshua Johnson from our Great Lakes Forestry Center that's actually leading the development on that. So he's the expert on that system.
Cool, thanks.
Certainly.
An anonymous attendee asks, how do you estimate the parameters used on the FWI? For example, DMC, DC, sorry, you're going to have to translate these acronyms for us.
Yes.
For example, DMC, DC across the country in locations where you don't have on-site stations.
All right. Okay. So yeah, in this chart, the acronyms are spelled out underneath each. So these are all the indexes that go into the fire weather index. So if you see a sign out in the forest that points to lower, higher, extreme fire danger, this is all the preliminary information that goes into that. So the field moisture codes, FFMC, DMC, DC, are just moisture bookkeeping systems in the forest floor. So FFMC represents the top couple layers of usually litter, so very coarse organic material. A bit below that, depth moisture code goes down to from about 2 to somewhere between 5 and 10 centimeters, and then below that is the drought code. So keep track of moisture and all those based on noon weather conditions. We do have, there's probably a couple thousand weather stations across the country that we uh, pull information from. Some of those are provincial fire management and fire weather stations. Others are operated by Environment Canada or NavCan or other agencies. But still, it does leave some gaps. So there is an interpolation process. So we tend to use information from the nearest X locations, usually about 8 to 12 locations, to try to estimate what the weather conditions are like between there. Admittedly, it's not perfectly accurate, especially with rainfall, because you can get very spotty rainfall showers or thunder showers that might hit a location but not be represented at the stations or vice versa. So, there are different interpolation methods to try to improve that. At some point, we might try to improve it by getting remote sensing observations of various types in there, and precipitation from with modeled output and radar is one example of that type. We're just not quite there yet to bring it into the system.
Cool. Now, at the beginning, when I introduced you, I said that we would go for 60 minutes, and we are near the end of that 60 minutes, but we still have a couple of questions.
Okay.
Do you have time to continue on for a little bit, or should we consider wrapping up, or what's your preference?
No, I've got time. This is the last thing I've got scheduled until about 2 o'clock today our time. So
Oh,
yeah,
great. So
I've
much.
got time.
So, but before I come back to Paul Kovacs' second question, I'd like to ask my second question. You've given us all the gory details about what climate models tell us about fire weather for this season. And some attendees might want you to offer some brief takeaway for them to tell colleagues and stuff, especially about climate change. What do you tell the press when they come and ask you about the long-term climate change signal? Do you have a soundbite about that?
Yeah, well, I think we've recognized that climate change is definitely affecting our fire seasons. Even though we see the number of fires dropping over the past 30 or 40 years, there's less human-caused fires, so people are probably being a bit more cautious out there. But at the same time, we're seeing a lot more area burned, by big fires. So when the fires do occur, they tend to be bigger and they're burning more area. So, in the past, we'd quote numbers like 3% of the fires caused 97% of the area burned. Well, now it's more like 6% of the fires caused 99% of the area burned. So those fires are getting bigger, they're getting more intense. And we've seen quite dramatic warming across the northern part of Canada. And of course, a lot of that area is part of the country where we see the most large fires up through the northern parts of the provinces and into the territories. So we're definitely seeing climate warming. You can pretty much eyeball it. In fact, in spring, like if you look at climate or weather conditions in Norman Wells, for example, in Northwest Territories, it doesn't take too much to really see an increase in temperatures there in the spring, and it's quite dramatic. And we see that through a lot of the northern part of Canada.
Okay, thanks.
So
So, so Paul's second question is that forecasting fire risk at the seasonal level is a skill and an art. Is the skill of seasonal wildfire forecasting improving with time? Does the U.S. Forest Service or some other group provide seasonal wildfire forecasts in the United States? Oh boy, A lot of questions here, Paul. And wildfire severity in the US and Canada often align.
Yeah, it's I guess, first of all, I think I'll address the US forecasting first. They do produce seasonal forecasts, and they've got a lot more people in regional areas that contribute their expertise to that. So it's probably more of a complex process than what we do here. We do take part in some international collaborations. So from Boise, Idaho, where the National, if I can get the acronym right here, the Incident Command Center, I think, NICC produces a monthly bulletin that highlights the seasonal forecast from both Canada, US, and Mexico, in fact. So we all contribute to that. Do they align? Well, we try to make things align the best we can at the international boundaries, but we do have years like 2023 where they've got a fairly quiet year going on, and ours is going insane. So, the forecasts don't always forecast the same things, and there are differences north and south of the border. So I guess skills is a tougher question. We've been doing computerized weather forecast modeling since about the 1950s, so 70 years of that. Over that period, there have been great improvements in it, but we still have a tough time getting a good forecast, more than 7 days out. With climate models, it's the same type of thing, slightly different process, and big improvements in these models probably occur more on the scale of a decade as opposed to year by year. So I think quite often they'll go through a development cycle, and once some new processes are ready, they'll roll it out into their models every few years. So it is a slow process, and we do try to monitor our skills somewhat. It's kind of buried in my GIS system at the moment, and it's kind of in its infancy as well. So, maybe in the future we could produce some type of our own skills map as well.
Mm. But big picture, long term, yes, our skills
Yes.
are awesome. An anonymous attendee asks, do your forecasts factor vegetation coverage and or their I think it's, do your forecasts factor in vegetation coverage or their dryness condition?
Yeah, not directly. That's the Fire Weather Index system here does not consider vegetation or topography at all. We do have the fire behavior prediction system that does use vegetation on a day-to-day type prediction, but we don't use it in the seasonal forecasting.
Okay, thanks.
That's why you might see an indication for a high fire potential in the southern parts of the prairie as well as agriculture and grassland. And normally June and July, it's everything's growing and you don't really get fire in that area, but the maps still show a red color there. So it's more important in the prairies, southern prairies, in the spring and the fall when the vegetation is dry. So you have to keep that in mind. It's not built into the forecast, but something that users should be aware of.
That's super interesting. Thanks.
Yeah.
Paul asks, we're holding this briefing on June 6th, and large fires have been burning for several weeks. In your opinion, what would be the best date to plan for a 2024 briefing about the expected wildfire season in Canada?
Yes, well, I think by the time we get into May, or predictions for the summer are starting to become a bit more accurate. Some of the forecast people they have a term, they call it the spring predictability barrier. It's kind of tough to wrap your tongue around that, but forecasts made early in the season, so March and April tend to show less skill, and we have a year like this where we've had that dramatic turnaround from our April to May forecast, and all of a sudden I think we're getting past that barrier and maybe getting a better look at summer. So it's probably good to do it in May. I mean, Alberta quite often has fires in May, but a lot of the the burning in the rest of the country actually occurs through the summer. So, it's this year is probably an exceptional case where we have this much activity right across the country by this time of year. So, I think most years it probably wouldn't matter too much if we did it in early June, but
So
yeah,
you're coming down on sticking with May in general rather than shifting it to June?
yeah, I think so. I mean, we do a very similar presentation through the Canadian Interagency Forest Fire Center, and usually that one's actually done in April. So we have to throw in that caveat that this is probably a little early to get the best prediction for the summer, but by the time we get into May, we're probably getting a better look at it.
Okay, great. That's the last of our questions. Do you have any last thoughts that you want to share with us?
Yeah, well, I guess whenever I'm talking to anybody, media or anything, I just keep reminding people to spread the message to be careful when conditions are dry and to keep monitoring conditions in your part of the country. So, it's quite important that people keep doing that. And I'm sure, especially in the spring, that maybe people can just kind of forget about that until something bad gets going. Then all of a sudden they're suddenly reminded that, hey, this is not good. We should respect the recommendations and rules. So, I always keep throwing that out there. And recently, I think this year, with there's been a lot of media attention on this as well. So you're going to see maybe quotes and some misquotes, which always unfortunately creep into some media reports. It's not done intentionally, but sometimes there's probably just a note that's written down wrong or something like that. And so it's hopefully with this type of presentation, we can get some good information out there. You're going to see all sorts of information from various CFS or government people from various departments. And we just went through a major press briefing on Monday this week, just yesterday, from Ottawa. So we had a lot of the Prime Minister and several of the ministers speaking, and some of our officials from various departments. So there's a lot of information that gets pushed out through those things. So yeah, a lot of things to sift through, but
Right.
quite interesting to look at them. Yeah.
Well, thank you so much, Richard Carr. We appreciate you coming to us every year with your forecast, and I want to thank our attendees for coming today, and remind you that the video and Richard's slides will be available on ICLR's webpage in the next day or so. Thanks everybody very much, and see you next time.
Right. Thanks very much, Keith, Michael, Tracy, and everybody that attended.